3 is steeper, right? See the radius is steeper there. It should be a number that's bigger than 1. And it's going to be the sine, change in y, divided by the cosine, the change in x. So it's root 3 over 2 divided by 1/2, which is root 3 over 2 times 2 over 1, which is just square root of 3. So tangent pi over 3 is root 3. Notice this pi over 6 is root 3 over 3. Tangent of that is root 3 over 3. It's 1/3 as big as pi over 3, right? This one's smaller because it's being divided by 3. This one's bigger because it's not being divided by 3. And here, square root of 3 is bigger than 1 because if you square them both, well here, if you square 1, you get 1. If you square root 3, you get 3, right? And 3 is bigger. All right, lastly, tangent of 0 is going to be 0 because it's going to be sine over cosine. 0 over 1 is 0, right? And the slope of a flat line is 0. And tangent of pi over 2 is undefined. Undefined because, well, you got 1 divided by 0, sine over cosine, cosine 0 there. So now if you wanted, right, cosecant, secant, or cotangent, you just got to do the reciprocal of each of those. You might have to rationalize a little bit, but that's okay. I'll leave you to handle that. So now what we're going to do is we're going to use what we know about our quadrant 1, sine, cosine, tangent, and our reference angles over here to evaluate each of these. So we're going to go sine of 4 pi over 3, cosine 4 pi over 3, tangent 4 pi over 3. So we're finding sine, cosine, and tangent for 4 pi over 3. We're going to go sine of 11 pi over 6, cosine 11 pi over 6, and tangent 11 pi over 6. We're going to do the same with 11 pi over 4. We're not going to do 14 pi over 4 because that reference angle was just the same. All right, so looking here, if I want 4 pi over 3 sine, cosine, and tangent of that, I look 4 pi over 3, right, the reference angle is pi over 3, and it's in quadrant 3, right? So that means we have sine is negative, y is negative, cosine's negative, tangent's positive. So I just look, reference angle is pi over 3, go to my pi over 3, root 3 over 2, but negative root 3 over 2. Cosine. Cosine at pi over 3 is 1/2, but because we're in quadrant 3, negative 1/2. And then I look here and I go, all right, tangent of pi over 3 is square root of 3. And because we're in quadrant 3, it's going to stay positive for the tangent because we have a positive slope there, right? It's negative divided by negative. And that's it, we got it. That's boom, we're done there. All right, let's look at 11 pi over 6. 11 pi over 6 has a reference angle of pi over 6. So we're going to be looking at all the pi over 6s. And it's in quadrant 4, right? Quadrant 4, which means cosine is positive, sine is negative, tangent is negative. So when I do my sine of pi over 6 is 1/2, but I'm in quadrant 4, so I'm going to say negative 1/2. Cosine of pi over 6 is root 3 over 2. I'm in quadrant 4, cosine's positive there, so it's a positive root 3 over 2. Tangent of pi over 6, right here is root 3 over 3, but because we're in quadrant 4, we're dropping from left to right, and we have a negative slope, it's going to be negative root 3 over 3. Right, I just used these 3 values, but these 2 are negative because we're in quadrant 4 from that angle. All right, if I'm at 11 pi over 4, here we're in quadrant 2. So that means cosine is negative, sine is positive, tangent's negative. So let's go ahead and just do it. So sine of 11 pi over 4, reference angle is pi over 4. it's going to be root 2 over 2, and it's positive. Because, right, we're in quadrant 2. Cosine 11 pi over 4, it's going to be negative, reference angle of pi over 4, root 2 over 2, so negative root 2 over 2. And tangent of 11 pi over 4, it's going to be the negative of the reference angle, which is at pi over 4, it's at 1, now it's going to be at negative 1. Right, you can use this thought process on any of these problems. And I would recommend that. If it's like, hey, find sine, cosine, tangent of some angle, find the reference angle, find what quadrant it's in, and then use this information to kind of piece it together. All right, hopefully you can do all the homework now. Sorry the video was a little long, but there's kind of a lot to put in there. Thank you for watching, and have a great day.